Hey folks, this is going to be a slightly different lecture video where I'm actually going to just do a drawing or more like written notes, pretty much like in normal class in person. These notes will be titled Balancing Chemical Equations. Part 2. We'll start off with one chemical equation. This equation is carbon monoxide, which is a toxic gas and released by cars as a uncombusted exhaust. The products here are solid carbon, that's just elemental carbon, and carbon dioxide. So this is a simple decomposition reaction where you have one thing breaking apart into two things. Now, in order to balance this equation, if you remember, I have to think about what do these atoms actually look like when they're in these molecules. And in order to really understand what the molecules look like, I have to remember what the numbers indicate here. So first off, let's talk about the little number that's here. This is called a subscript. And a subscript, sub means under, and script means writing. So this is the writing underneath. So the CO, and then the 2 is down low, and it's little. Now, as you're taking those notes, I'll read this out to you briefly, some of the important points. The subscript is this little number under the element it refers to, and they're always to the right of the element that they refer to. So the 2 is in reference to the oxygen. If you saw something like H2O, people sometimes wonder, does the 2 refer to the O or to the H? It's always to the right of the element it refers to. So the 2 is in reference to the H. What about the O? Well, does the O actually have a subscript? It actually does. The O has a 1 right here, but we don't bother writing the number 1 because it's implied if you write the letter at all that there's at least one of those. So all of these letters, since they don't have subscripts, have the letter 1 as their subscript, but it's implied. Okay, so this number indicates how many atoms there are in a molecular compound of that element, okay? Now this element, oxygen, has a 2 below it, so there are 2 molecules of oxygen, atoms of oxygen in the molecule CO2. To show that to you, let me present a couple diagrams of these molecules, okay? So this molecule is carbon monoxide, CO, and this molecule is carbon dioxide, CO2. And you'll notice that because there's a 2, there are 2 oxygens around the carbon being the brown one in the middle. And because there's only one of each of these, then this molecule actually looks like this. So these two are very different molecules. Even though they have the same elements, they operate very differently. Chemistry really cares about how many things there are and in terms of molecules and how they interact. We breathe out CO2 in our breath, but if we come into contact with carbon monoxide, we can actually die. So carbon dioxide is non-lethal. Carbon monoxide can actually kill you. So there are very big differences between just one atom. So thinking about that, let's think a bit about how we can then balance this equation. Because the point of a chemical equation is that it helps us understand not only how a reaction would happen, but we also want to know how much is going to be produced or how much is needed, sort of like a recipe. So the best way that I can detail on how to really get one of these equations balanced consistently is the following. And I'll give you a step-by-step guide to this in just a minute. So first, what you're going to do is draw a line right where there's an arrow. So hopefully you're following along with me, and you've got this drawn and the notes here. And you've got a line now drawn right below the arrow. That's always the first step, is to draw the line that's really dividing between reactants and products. So reactants on the left, products on the right. The next step is to start listing the elements that are reactants and the elements that are products. Now, of course, you can't have anything besides what you start out with. So I can list the reactants as C and O, but when I'm going to list the products, they can't be anything other than C and O if that's all I have to start with. They have to be the same. And so I always encourage you to just to do counting and to double check that you haven't missed anything. But if it is a true equation, it can't have new elements over here. There can't be chlorine or gold or something. It can't just appear over here and not have started over here. All that chemical reactions are basically a rearrangement of bonds. So when we are trying to do the balancing for this, the first step is to draw the line and then list the elements. The next step is to count. So we're going to go ahead and count the number of carbon atoms and the number of oxygen atoms. That was pretty easy. Now let's count the number of carbon atoms on the right side. There are actually 2. And the number of oxygen atoms. There are also 2. Now, to balance this, I need both those numbers to be the same, because what this tells me is that I started off with 1 carbon atom and 1 oxygen atom, but I need 2 carbon atoms and 2 oxygen atoms. I thought it might be helpful just to put that extra carbon atom in there, just so you could see it visually. There is a difference between these molecules, obviously, but this is really the chemical equation we're talking about. So reactants and products. So how do I get this stuff if it only starts off with 2? Well, in order to do that, I just need to have 2 carbon monoxide molecules. And if I do that, then I'll actually have 2 carbon atoms and 2 oxygen atoms. Okay, there. Now everything balances. 2 carbon atoms, carbon monoxide molecules, 1 carbon atom, and 1 carbon dioxide molecule. This is a balanced equation, and this is why, because I have the same number of atoms on this side as I do atoms on this side, and they're the same type as well. 2 carbons, and 2 oxygens and 2 oxygens. So that's the logic behind it. Now, I did add a second kind of number, and I want to define that number right there. You notice it's big, and you notice it's in front of a molecule. Let's go ahead and define that. This is called a coefficient. Now, the coefficient is the large number that's in front of a molecule or element that tells you how many molecules or elements you have. So in this case, I have 2 carbon monoxide molecules. Similarly, to the subscript, I have not written a coefficient in front of carbon, but it's implied that there is 1. I have also not written a coefficient in front of carbon dioxide, but it is also implied that there is 1. So the ratios here and the coefficients right across from left to right is 2, 1, and 1. Okay. Now, that number is very important that you understand how to use it, because it's how you balance. You can't do anything with the subscripts. You can't take them away. You can't add a subscript wherever you want it to be. So you're not allowed to move subscripts. You can only add coefficients, and you can't take away anything out of the reaction. Sometimes students will say, oh, if I have too many carbons, can I just take that one away? Well, no, it's part of the reaction. So you can't just take it away because you don't like it. It has to stay. All you can do with balancing is add coefficients. And coefficients always have to be whole numbers, okay? Always have to be whole numbers, and they always have to go in front of whole molecules. They can't go in between the two. because remember, this is a molecule which cannot be split or separated. You can't have one of these and not also one of these. You have to have both so that you end up having two atoms or two molecules. You can't have half of a molecule, right? That would be an atom and that would be different. You have to have them both together. Okay? Okay, so again, these are the only way to balance an equation, and they must be whole numbers. Okay. Let's go ahead and apply this method to a list of rules on how to do balancing chemical equations. I'm going to go ahead and list them as 5 steps. Okay, step 1. The first step is to write out the entire equation like we did at the beginning. I want to say something briefly about this one. If you're given a problem online, this is still so essential because even though you have it on the screen, you can't touch it until it gets on your paper, and you can't really do any good thinking unless it's done on paper. This method is not friendly to online, obviously, because it has to be done on paper. It takes very little time to actually write the equation out, and then it's well worth it so that you can do this process. But it's so essential that you do actually go through this process that I want to encourage you, do not skip actually doing these steps or trying to do it in your head. It's much too difficult to keep it all in your head. So write out the equation, and when you do that, be careful. Because if you make any mistakes, then that equation will be wrong and your balancing will be wrong. So be careful when you transcribe it from an online source to another source if you make a mistake. Double check. Okay, step 2. Okay, so the first step is to draw that line at the arrow like we did here, and then listing the reactants and the products, one atom at a time. Do not list molecules, just list the atoms. After you do that, double check that you've put them in the same order because you're going to be comparing each line 2 to 2 and 2 to 2. And you want to make sure that they are the same element from left to right, that they are both oxygen or both carbon. So make sure that you've listed them in the same order. Okay, step 3, count the number of each type of element on both sides of the equation. So go ahead and count them up before you do anything to the coefficients. Okay, step 4, identify which element there is not enough of and then add a coefficient to the chemical to increase its quantity so it matches the other side. Okay, so it's got to match the other side in order to balance, and you can use either a product and start adding coefficients to the product side, or a reactant, add coefficients to the reactant side, whichever one it needs the coefficient added. So it doesn't matter which side it's on, you can add coefficients to either side. Okay, step 5, repeat. Repeat steps 3 and 4 until the equation is balanced. And that is the goal, to get to a balanced equation where both sides have equal amounts. Okay, that's the steps. Now we're going to go through those steps one at a time as we look at some harder problems. Okay, well, let's start with the first equation. So phosphorus and chlorine, these are two elements, and there's a 5, and that produces phosphorus chloride with chlorine gas. Okay, so let's go ahead and balance this equation and see, oops, I forgot to add. Go ahead and make sure that you've written this down, and let's do some balancing. First step is to draw the line, then to list the elements on each side, And now to count. Chlorine is on this side with 5. It's on this side with 3 and 2. Wait a minute, that is 5 and 5. So this one's already balanced. Sometimes equations are balanced from the get-go, but often they're not. Okay, let's try a harder one. Okay, now this is a combustion reaction where we have a fuel, carbon-based fuel reacting with oxygen, making carbon dioxide and water. Let's do our steps again. The first step was to draw the line. Okay, so refer to your steps here. We wrote it out and then draw the line. Then we're going to list all of the different elements. Now you notice there are 3 elements in this one. So when you're starting to list them, just go from left to right. Carbon first, then hydrogen, then oxygen. Now you'll notice it goes carbon, oxygen, hydrogen, oxygen on the product side. But go in the same order that you did the reactants, because that way you can actually match them up, and it's far easier to balance it that way. Let's count. Now for oxygen, you want to look and see, okay, there are 2 here, but there's 1 over there. So there's actually 3 oxygens in this equation. Okay, let's go ahead and start balancing. Let's start with the top. Let's do carbon first. Now I've got too few carbons on this side, and I need to add more so that I get to 2. So I'm going to put a coefficient of 2 right here, and now instead of 1, I have 2. So I cross out the 1 and I get a 2. Okay, these are balanced. Let's go with the hydrogens now. I need to add 2 hydrogens to get to 4. How can I do that? Well, now I have to think, okay, I have a water molecule with H2. There are 2 hydrogens in this molecule. If I had 2 molecules of water, I would have 4 molecules of atoms of hydrogen. So I put a 2 in front and I'll get 4. Another way to think about this is that it's 2 times whatever is in the subscript. 2 times 2 in this case is 4. Now, I did do a bit of a kind of an error earlier where I took the 2 and I multiplied it to the carbon, but I didn't actually update my oxygen values. And that was probably a mistake. It's important to always do that first, but it's okay because we haven't really looked at oxygen yet. But it is always good to update it as you go. Let's go ahead and just do that. The 2 times 2 here is 4. So 2 times 1, remember there's a little 1 here. It's implied. So 2 times 1 was 2. 2 times 2 is 4. And now I've added the 2 over here. 2 times 2 is 4. And 2 times the little 1 that's down here, 2 times 1 is 2. So how much is that altogether? There's 4 oxygens here. There's 2 oxygens here. And I add them together and I get 6. Okay. So hopefully I didn't lose you there. But it's really just adding up all the molecules you have, and in particular looking and focusing on the particular elements that are in those molecules. So I'm looking at just the oxygens here, and I notice, of course, that my oxygens are not balanced, but everything else is. Well, this is convenient because I just have to balance the oxygens on this side, and I have an oxygen molecule here that's that I can tell is divisible, into 6. I can put 6. I can make 2 go into 6. And how do I do that? I can make 3 of them. 3 times 2 is 6. So you can kind of use your times tables here to think a little bit about where things are going to go and how much of something you'll need. So the numbers here, remember there's a 1 here. There's always a 1 in front unless we put a different number. The coefficients are 1, 3, 2, and 2. Okay, so if you follow those 5 steps, you will be able to solve any equation I throw at you, so long as you keep to those 5 steps and you're very careful about how you do your math and copying, okay? So stick with that, and I think you'll be fine. I hope that was helpful.